Alright guys, so question 10 is asking what is the isomeric relationship between the following compounds? And so what we're going to want to do for this is we're going to want to either figure out the configurations, that is RS, for each compound and relate them, or an easier way of attacking this problem is that we're going to figure out the cis or trans relationship of both compounds and then compare them to one another. And so we're going to use that route, and we're going to start with B just because it has an easier perspective, and we can see that we've got all cis going on because they all have the same wedge coming out. So if we're looking at just 1, 2, we see that we have 1, 2 cis, and then we have a 1, 3 cis as well. Okay, so now looking at this compound, we see that we have a 1, 2, so we got 1, 2, EE, which thinking back to our table, that would make it a 1, 2 trans. And then we have a 1, 3 EE, which thinking again back to our table would make that a cis. Okay, so this right here is actually sufficient information to let us know that we actually have a diastereomeric relationship between the two. 1, 3 is identical, but the 1, 2 is a cis and trans, which are diastereomers of one another. But let's just go ahead and take this a little further to really illustrate that point. So now what we're going to do is we're going to turn this into this same perspective so that we can get a better idea of what it is that we're actually looking at. So I'm just going to throw that over here, and we're going to draw out this compound in a different perspective, A compound, and we've got a 1, 2 trans, so we'll just draw 1, 2 trans, and then 1, 3 cis. So 1, 3 need to be cis to one another, so we'll draw it like that. Okay. So now we'll go ahead and compare these two compounds, which is essentially this is the A compound, just in a different perspective. And in comparing those two, we can see that they're clearly not identical. Okay? And they have to have some sort of isomeric relationship because they have the chiral centers there. So even if they're not identical, they must have some sort of isomeric relationship. So we can cross that one out. They are not constitutional isomers because a constitutional isomer is the same molecular formula in a different arrangement, but in this case we have the same arrangement, we just have different stereoisometry. So we can cross that one out as well. And then lastly, we can also actually eliminate the enantiomer because enantiomers are mirror images of one another, and we can see here clearly that if we were to draw a mirror in between those two, that they would not be mirror images of one another. This actually is also a meso compound, so its mirror image is going to be identical. And then so lastly, that leaves us with diastereomers. And so just going back to that point that the 1, 2 positions on both of these compounds end up being cis and trans to one another, making them diastereomers, while the 1, 3 is just identical. And so that's why our final answer would be diastereomeric relationship between the two compounds.